Greetings to all. Firstly, I would like to thank Smart India Hackathon for giving us the opportunity to work on this wonderful project. The problem statement we have taken up is FloatChat, AI powered conversational interface for ARGO ocean data discovery and visualization. The first question is, what problem are we trying to solve? Marine researchers spend 80% of their time collecting data sets, making it near to impossible for them to generate insights. Thousands of Argo floats generate terabytes of data daily. Our solution to this is an AI powered interface which will help visualize and democratize Argo datasets. We are providing support for 22 Indian languages, voice control, automated scientific document generation, and contextual responses with citations. We are also incorporating a 1D diffusion model which will improve future forecasting. We are also having live dashboards and web-based Argo Float deployment simulator for training datasets. For our product, we have tried to incorporate a microservice type architecture. We built front-end on Next.js 14 with WebGL for immersive 3D ocean visualization, Mapbox GLJS for geospatial mapping, and observable plot for dynamic charts. Our API gateway is powered by Bun plus Hono.js, delivering event updates in under 1 millisecond using Redis streams. The AI and ML layer uses Python Fast API with LangChain orchestration connected to a QDRAN vector database. Our RAG pipeline achieves 94% SQL accuracy and even scales to zero when idle, saving cloud costs. Data pipeline is done using Apache Arrow for zero copy data streaming, converting raw NetCDF files into Arrow type files and then park it. This reduces data processing by time by 65%. For storage, ocean profiles are indexed in PostgreSQL plus PostGIS with MinIO S3 bucket handling raw NetCDF storage at 99.9% uptime. For monitoring, we rely on Prometheus and Grafana for real-time system monitoring. Now I would like to show you the demo of our website. This is how the front-end UI of our website looks like. It has a 2D maps interface which is very interactive and can be used by anyone. We can also switch to a globe view which is again very interactive and easy to use. It has a sidebar which contains various research filters for configuring data visualization parameters. It has a dozen of dataset filters which you can use. Again, you can also give some deployment period from which time you want to see the Argos dataset and all. We also have an AI chatbot assistant in our program. So let's ask something. Tell me something about Argo floats. So it has started giving some, okay, so it has already generated it in a few milliseconds, and we can also resize the the chat area so that we can easily view whatever it has given. So it has provided me a good amount of data to read and understand about Argo floats. So now if you click on any one of these points, which are actually the Argo floats deployed near the Arabian Sea and Bay of Bengal, and just check for their profile, we'll go to a new page where an oceanographic data analysis page will open, and at the left hand side you will have float information, cycle information, a mini map showing the position of the float right now, the data quality, what kind of data is it providing. It also has a lot of graphs to show you the individual profiles like sea temperature, practical salinity, dissolved oxygen, pH profile, nitrate profile, chlorophyll A. It also has temperature salinity diagram, and again it also has an AI generated insight which will analyze the graphs and give you some kind of output. So if you generate something, it will take hardly a few seconds and generate some insights like the water mass analysis, parameter correlations, biogeochemical insights, key findings, which is very helpful for researchers and normal people in order to analyze the graphs. There is a multi-parameter depth profile graph. Again, it also has this kind of a analyzer, AI analyzer. Again, it will take a few seconds and analyze the graph, biogeochemical graphs. And if you want, you can download a dataset in any of these three formats: CSV, NetCDF, and JSON format. If I go back again and check some trajectory, how has the float been moving around? So it has been moving around like this. It started from here, it has ended here, and there is again a lot of information about it, the analysis, the graphs. It has a huge amount of data available, monitoring battery health level, many things are there. Profiles, quality, metadata. So this is all about the UI and of the website. Let us talk about how these will benefit and what impacts it will make. Now let us talk about the feasibility and viability of our product. There are some few key points which I need to mention. LLM API costs are managed with Grok inference, which are 10 times cheaper than standard APIs, and we will also incorporate local Llama fallback with caching. Real-time performance is guaranteed through Redis streams and WebGL optimization. Data quality is improved with automated validation and user feedback loops. As a result, we cut cloud costs by 90% while delivering 100 millisecond response times. What impacts and benefits are we making? There are a few points mentioned. Fishermen and coastal communities can ask forecasts in their own language and cut risky trips by 30%. Policymakers get one-click PDF bulletins with live uncertainty cones, improving cyclone evacuation ROI. Scientists save 1200 plus hours a year by replacing ad hoc scripts with instant queries. Shipping operations save up to 80 lakhs rupees per ship annually through optimized routing. So that's FloatChat, a conversational AI for ocean data that combines cutting edge AI, real time pipelines, and intuitive visualization. If you want to try it yourself, the demo link is there in the PPT. Thanks for watching. Have a nice day.